This meeting is being recorded.
In problem 10 from chapter 20, we are asked to identify the reagents that could be used to achieve these transformations shown below. So we have A through F, and in part A here, we see ethanol. So I've drawn the structure out here. We have ethanol being converted to acetic acid. And since my starting material is an alcohol, ethanol specifically, this would correspond to a carboxylic acid with two carbons. So we see 2 carbons here, 2 carbons here in our product. So we don't need to add any carbons to our carbon skeleton. So we can probably accomplish this in a one set of reagents rather to accomplish this, which we could use in this case. Chromic acid, which we could generate using sodium dichromate, Cr2O7, and sulfuric acid. And then we also need water with these two reagents as well. So we can accomplish this again with one step and a workup step. Using the strong oxidizing agent to convert our alcohol, in this case a primary alcohol, to a carboxylic acid. All right, let's see. In part B, now we have toluene, so that structure is drawn here. We have that benzene with a methyl substituent. So to convert an alkyl group on a benzene ring to a carboxylic acid, we can oxidize at the benzylic position, so that's shown over here in our product, to a carboxylic acid in, again, one step using that sodium dichromate and sulfuric acid to generate chromic acid. And then we have our water as well. So those are the reagents to use for parts A and B. Let's take a look at what we can do in part C here. Now we start with benzene, which doesn't have any activators on the ring. So we have to add an additional step to convert this to benzoic acid now. So let's take a look here. First, we could do this. We'll install an additional carbon atom on our carbon skeleton using a Friedel-Crafts alkylation. So we can see down here, we could use AlCl3, our aluminum, trichloride, and then methyl chloride here as our reagents to do a Friedel-Crafts alkylation. And we see that we've installed that methyl substituent now. And then just like we did with toluene earlier, we can use our sodium dichromate here, sulfuric, SO4, and water to oxidize at our benzylic position and generate benzoic acid. Okay, so now we have the reagents or needed for part D here for this transformation. We start with 1 bromobutane. So that's shown down here, right? We have 1, 2, 3, 4 carbons in our chain, but now we have 5 carbons. Oh, we should only have 5 carbons in our product here. So we have our pentanoic acid. So we need to propose a synthesis that involves installation of a 5th carbon atom. So we could do that in a couple ways. So here we'll go up top here. We could use in step 1, we could do a substitution-like reaction here, SN2-like reaction, and install a cyano substituent where this bromine group is. So we can extend our carbon chain that way. And then we could reduce that nitrile group that we added using aqueous acid and heat. So that could generate or oxidize rather that group, that cyano group, to turn it into this carboxylic acid. Or we could take this path below here and we could create a Grignard reagent. We could add magnesium, carbon dioxide, and then we can add aqueous acid in this last step here. And that could generate our same product here, our carboxylic acid, our pentanoic acid. All right, so we have two last reactions here. I'm going to slide down. So we're going to see ethylbenzene converted to benzoic acid, and then bromocyclohexane transformed to cyclohexane carboxylic acid. So in part E, again, we have that our ethylbenzene converted to benzoic acid. So we can oxidize at the benzylic position here. But notice we're going to get benzoic acid. So we actually cleave this carbon-carbon single bond here. And when we convert that benzylic position to a carboxylic acid, we lose one of those carbons. So we're going to use the same reagents as before, the sodium dichromate and sulfuric acid and water to generate benzoic acid from our ethylbenzene. In our last transformation here, we have two different paths we could take. So we have our bromocyclohexane. We could, in 2 steps here, do an SN2 reaction using sodium cyanide, replace that bromo group with a nitrile group, functional group, and then in using aqueous acid, we can oxidize and heat here to generate our carboxylic acid, our product, our cyclohexane carboxylic acid product here. Or we could take a second pathway here using the Grignard approach. So we could add magnesium, then we could use CO2, and then aqueous acid in a third step here, and that would also generate our cyclohexane carboxylic acid product.